Okay, and now without further ado, here's Alvin, the VP of Product at Aerospike.
Thanks, everybody. Okay, so let's do a quick raise of hands. Who uses Docker at the moment? Okay, who uses Docker in production? Oh, a couple of braves. Oh, you work for Docker. I'm going to rule you out straight away. Who uses Aerospike? There's a couple of errors. Okay, so you're going to know some stuff about Docker in that case, so I'll go through those bits quickly, and then I'll try and describe why Aerospike is a really interesting thing for you to go and try. Okay, I'll start with the conclusion. The conclusion is pretty simple, which is containers and databases for developers is a super happy thing. They grin broadly, and life is very good for them. For the DevOps people who actually have to put this in production and keep it in production, there are several headaches that you have to go figure out. Everything from data redundancy, discovery, healing, and a whole bunch of other attributes. So what we're going to spend most of this talk about is how do I worry about some of those things to ensure that if I put my databases into production, I can scale and my data is reliable and all those kind of good things that you care about data. So my basic premise is that everything's broken. If you start off with your kind of traditional application environment where you've got a database at the bottom and then you've put a cache in to improve performance, and then you've probably got some data lake where you're doing some offline analytics to try and feed back into your decision-making systems, you've ended up with some kind of cornucopia of complexity that you're probably not desperately happy about. And if you're trying to actually push all this stuff out, you've got a fairly complex deployment, you've got some CI loop and a version control system, and then it gets pushed to test, and then eventually gets pushed to production, and those things don't look quite the same. The Ansible scripts are different, the hardware's different, and then something goes bang in production. The developer says, hey, I can't reproduce this, please get me onto production so I can debug live. And the ops team go, over my dead body, will you do that? And then so, you know, much hilarity ensues after that. And so let's just assume deployment architectures are broken. And then you've got modern computing architectures. You know, in the old days, or the present days, you've got a database that's running on top of a file system, and that's got a nice page cache between you, and then there's the block interface, the device, and you have to go through all of those layers to simply read and write a block of data. And so, you know, with kind of modern day SSDs, especially NVMe drives, wouldn't it be better if your database could use memory and then parallelize all of those writes directly to the SSDs without all of those layers in between? Isn't there a whole bunch of inefficiency in this stack? So my basic premise to that is there is a lot of inefficiencies, and it's kind of somewhat, you know, hidden by the fact that you can go to Amazon and spin up 1,000 nodes, but who really wants to manage 1,000 nodes? I kind of think of, you know, it's like children. You know, I've got 2 children. My first child was great. My second child was pretty good as well. I certainly don't want to have 1,000 children to try and manage and organize and get their socks on and blah, 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 blah. So let's keep things simple as best as we can. So what we're trying to do is meet a bunch of challenges. We're going to use containers for encapsulation, for isolation, and databases for persistence and all that kind of good stuff. So let's keep those in mind as we kind of look at this architecture. Now, I think what we will do is I'm going to do a couple more slides, and there's some marketing things because they forced me to do that. And then I'm actually going to open up a terminal and we're going to do some live coding and a live demo. Now, I do have my Banjot here is my token. Last time I did this to a very large audience, it went bang in front of 3,000 people. I blame my dear former colleague personally for this. So there's every chance that this might blow up as well. But we will do it live just for giggles, right? Okay, I see. Okay, containers. So if we think about containers, what do we use them for? Well, you're all Docker people, you understand all of this stuff. you kind of want to build, ship and run. Under that you've got a bunch of open standard specs for the runtime. You've got the plumbing, so you can actually execute those standard images, and then you've got clustering and distribution on top of that. So kind of essentially Docker is there to support your life cycle. So what do containers give me? I think of them as two basic things. One is the encapsulation of your dependencies. So, you know, which version of the language do you need? Which packages do you want installed? Which distribution of Linux do you want to run on? And then after you've got all of those dependencies encapsulated in your image, when you run it, you want to guarantee that there's some process isolation. If you think about why you mostly use virtual machines, yeah, it's great that you can spin up a virtual machine, but it gives you some isolation from what else is running on that box. I can put policies around those virtual machines that constrain memory or IOPS or memory bandwidth. And so the one way to think about containers is faster, lighter weight VMs. And my dear friends from Docker will come and axe murder me for that, but I'm a simple guy, I like to keep things simple. Okay, here's an example of a Docker file. Who's ever written a Docker file before? Then this is all obvious. Okay, so all we do is, it's a sequential set of essentially dependencies. I'm going to use Python 2.7. I'm going to add all of the code in this current directory. I'm going to run and install some packages on the Linux machine. Then I'm going to do this is Python, so I'm going to do a pip install for the rest of my dependencies. Right, so this is all pretty simple. It's nice and declarative. I can read it. I can understand what's doing. And the way I think of it, an image, because we're defining an image here, it's an envelope. I'm opening up the envelope, I'm stuffing all of these things in, I close the envelope up, and then I can give that envelope over to you, and you're going to have the same set of dependencies, the same code. So no matter whether I give it to you, because you're my friend I develop with, or my friend over there, she runs all the infrastructure, we get the same images, we get the same things we run. And so that's kind of pretty cool, I kind of like that. There is the Open Container Initiative, so obviously Docker is in there and CoreOS. Essentially there is a group of body out there, it's under the Linux Foundation to ensure that the image standards are common, and therefore you're not going to get vendor lock-in from using vendor A's a container standard versus vendor B's. So for you going down the road on this voyage, that means you're not going to hit a path or a blockage at the end of the road where, oh my god, I bought it from vendor X and I have to stay with vendor X the rest of my life. And that's kind of what essentially the Open Container Initiative is there to try and do, to avoid that. I kind of trying to think of, you know, Docker in terms of pictures. You know, I'm a visual type of person. So right at the top here you've got a container. Well, a container is where it's an encapsulation of your code and dependencies. Your container runs in a Docker engine. Oh, I understand what's going on now. I printed out the PDF and I didn't subtract all of the hidden slides. So this is why there's some extra slides in here. I'm going, why are these slides here? Okay, now I know why. So here is my container. Your container runs in a Docker engine. How do you get that Docker engine in the first place? You can use Docker Machine to go provision those engines, either on your laptop or in some cloud or dedicated infrastructure. If I want to run multiple of those engines, I can use Docker Swarm as a basic clustering algorithm to cluster these engines together. And when I want to compose my application as part of all these services, I can use Docker Compose to deploy that either to a single engine or out to a swarm. And so that's how some of these basic technologies all fit together. And as I said, I tend to think of this in pictures. Okay, who wants to know about Aerospike? Wow, thank you very much. I love you guys already. Obviously, we need to give plenty more screwdrivers away. Okay, so here's the bottom line. This is a real customer case. Going from 186 servers to 14 and still doing the same number of transactions a second really kind of changes the way that you think about the data you can now process and the cost to process that data. Historically, our kind of customers have been in ad tech, and if you think about ad tech, those people who put those awesome adverts on every page on your mobile device, They want to build richer and richer algorithms to give you a more personalized experience. They need to process a lot of data very quickly because they've got 75 milliseconds in order to bid. And so you can go build out very fast performant clusters. How do we do that? The scaling is fairly simple in that you can think of Aerospike as one huge hash table, and we use a hashing algorithm of RIPE-MD 160 to hash into partitions. Those partitions are then spread across the nodes. It's a shared nothing architecture. So each one of those nodes is of equal value and equal importance. There's no special nodes in that configuration. And so what this allows us to do is very simply dynamically add and remove nodes. So you add a new node into the cluster, the data gets redistributed around that cluster. You remove a node, we'll then again rebalance and migrate data. It's got the ability to auto-heal, but it's also, like most modern NoSQL databases, it's also schemaless. Right, so if you're dealing with a high variety of data, it's easy to go and put that in. We support all the typical scalars and lists and maps and other rich data types. Okay, how do we do on speed? Essentially, Aerospike has been built with a log structured file system, optimized for Flash. So very early on we went, Flash is the future, even though this was 2009. We said Flash is going to be the way that people are going to get IOPS. Flash is going to look more like DRAM over time. It's going to get faster and faster, the capacity is going to increase. So we built essentially a log structured file system and a key value store on top of that. And essentially that allows us to build in great features like TTL. So you've got time to live, you can auto expire data, you can blend data between pure DRAM and Flash, so you don't have to use just DRAM. And it gives you these kind of wonderful characteristics where on a YCSB benchmark you can get 10 to 20x better throughput or lower latency depending on what you care about. Okay. And a use case, this is a sort of typical use case we see, so real-time fraud prevention, God that's difficult to say, especially after several pints of vodka, or it's actually really water. A typical use case is, if you think about the time when you swipe your card, there's about 750 milliseconds before you have to either accept the transaction or decline it back on the terminal. And you've all been there where you swipe your card and it's got declined. How do you feel about a declined transaction? You kind of feel kind of shitty, to be honest. And what do you now do? You pull out another credit card and you swipe that. Right? So for that vendor, they've just lost that transaction. And so why did they lose that transaction? Well, they didn't have enough data to compute whether it was a fraudulent transaction or not. So imagine you swipe your credit card at SFO and bought a cup of coffee, and 14 hours later you swipe the credit card again and buy a cup of coffee in London. Should you accept that transaction? Well, if I know those two transactions have just occurred and I've brought a flight with this credit card to do that leg, and I've been to Europe 5 times this year, I might choose to approve it rather than decline it. And so what they're doing in credit card, in fraud detection, is wanting to look at bigger and bigger graphs of data. Sometimes this could be 200-300 data points that they want to analyze in order to make a decision. They want to combine this with their data lake, where they're doing all of their machine learning, and the results of those models feed back into the real-time cache, where they can compare the models of behavior with the real-time transactional data in order to make a better choice. So we kind of see this pattern in fraud prevention. We see it in ad tech, e-commerce, telco as well, where you want to make real-time decisions on bigger and bigger graphs of data. Okay, I'll take a slight pause at this point. Questions about Aerospike before I move on? You're all blinded with science. This is awesome. I have clearly won you all over. All right, databases and containers. What's cool about that? So you can run your application in a container, and that's pretty cool. Your application is generally stateless, and so given a container is ephemeral, when that container disappears, you lose the application, but you don't really, there's no consequences because the application's stateless. There may be a downgrade in user behavior because they suddenly do a page refresh and get a 404, but you know, you can go figure that out with fancy load balancing. But what about your database? So you put a database in a container and the container's ephemeral and the database goes, container goes away. Are you okay about losing all your data? My dear friend over here is shaking his head. Anybody likes losing data? The general consensus is no. So what do you need? You need to think about data redundancy. You've got to have multiple copies of this data to survive the fact that you might lose a node with some of that data. You want to, as you scale out your data tier, you want that to kind of self-form and self-cluster. You don't want to be sitting there at a terminal each time you start a container trying to do self-discovery and reconfigure the whole cluster on the fly. Right? That would be tiresome. Obviously, if containers die or you take containers away, you want the cluster to reform. And finally, you want to think about, from your application point of view, each time I change the topology of that cluster, I don't want to have to go reconfigure the application with connect strings. So how does Aerospike fit up with that? Well, data redundancy, we've got the automatic ability to replicate data within the cluster. You can choose how many copies you want, 2, 3, 4, 5, how many of you need. Our protocol is self-discovery, so as soon as a node sees another node, they go, hey, I'm a node. They go, want to join our cluster? And go, yeah, you can come and join our cluster. And go, oh, let's party on, dude. And they kind of form this cluster, and then they decide that they can shuffle the data around in order to balance out the load across the system. Clearly, as nodes disappear, you want the topology to reform and it to rebalance itself. But finally, all of our database clients, you know, Java, C#, Python, all the languages that you know and love, they've got inbuilt ability to understand what the current topology of the cluster looks like. So as nodes disappear, they automatically reconfigure, so you don't actually have to change any configuration in that client in order to take advantage of the new shape of the cluster. It's all done automatically. And as we'll see in the demo, we can go and add nodes to the cluster and the application carries on working. You don't have to actually change any code to take advantage of that. Okay, question?
That's a question. You said you do multi-path and mesh networking. Can you say more about the mesh networking?
Yep, so the question is, how do we do our clustering? There's two forms of clustering. There's multicast, which is great on typically dedicated infrastructure. Services like EC2 and Docker itself doesn't actually support multicast and all the different networks. So we have a protocol called the mesh protocol, which essentially you can automatically send a command to inform the other nodes of the cluster. And we'll show how we can integrate with that mesh networking in the demo coming up.
So this is a logical mesh, not a physical mesh.
Correct. Okay, so the demo. So we're going to try and go from development to production. And the great thing about going to development to production is that the developers can focus on the things that they care about. What you want as you go through that life cycle is to inject additional behavior. You may have security requirements, you may want to have additional packages installed, you may have additional affinity rules that you want to inject to reflect what you want to run in production. We're going to scale out our web tier behind an HA proxy, a load balancer, and then we're going to scale out our database tier. So we're going to start off pretty simple. We're going to start off in our developer environment where we have a Python Flask app, and we have built the most awesome application you've ever seen in your life. You're going to be stunned by what we're going to be doing. And then we're going to have an Aerospike cluster, or a single node. And then we're going to end up with an HA proxy with a whole number of web nodes running, and then we're going to scale out our Aerospike cluster underneath. Right, so that's where we're going to start. That's going to be our destination. There may be some demo failures in the middle. We'll see what happens. All right, let's go build an application. So, Okay, so here is our small little Flask app. So standard set of Python imports. I think the first interesting thing we come up is what we need to do is we need to establish a connection to the cluster. And so we can see aerospike.client connect. So that's how we go and establish a connection to the cluster. Now, Aerospike is a key value store. So we write data with a put. If I can highlight that, it's not going to highlight for me. There you go. So we're going to do a put here. And so we're going to put some data. And as you can see in the next couple of lines, we're going to increment some counters. And then we're going to actually perform a query to go get a key to get some value out. So we're going to insert some data. We're going to do 2 updates. We're going to do a query. Okay, pretty simple stuff. So let us get this up and running. And I've actually encapsulated all of this in a Docker Compose file. So let me just kick that off. And as you can see, we've got 2 services defined, and we'll look at those services in a second. So it's all running. Who wants to see the running application? I think there's at least 1, 2. Thank you, sir. All right. It's a hard crowd tonight. Okay. Let's get that. All right. So let's do a page refresh here. And I have built the most awesome scalable hit counter. All right. So if I do a page refresh, I can carry on counting page hits. Now, I think this is going to be the most, talked about article on Hacker News anytime soon that we've built this scalable hit counter. Look, it carries on working. Isn't that awesome? So essentially, all we've got is a small application that takes that page. It's going to do all the database operations to keep all our statistics up to date. So let's have a look to see how we did do that. So here's our Docker Compose file. Who's used Docker Compose? A few of you, okay. So some of this will be familiar to you. What we've defined is 2 services, the web service and the Aerospike service. And in our web service, we're going to put a build command, which is just going to tell us how to build that image from that previous Docker file that we saw that specified Python and all the other packages. We're going to expose some ports. We're going to use the link to say, I want to link these 2 containers. So that's just going to establish the fact that they can talk to each other. I'm going to give it a host name, which is not particularly important. I'm going to set an environment variable to pass through, so we could set environment variables. And on my Aerospike service, instead of building from the source code, from our Python file, I'm going to use an image that's hosted on Docker Hub. And if you haven't used Docker Hub, it's just a central place where you can go get published images. You can put your own images up there so they can be downloaded and used elsewhere. And I'm sure my friends over at Docker will tell you all about, you can actually get the same registry behavior on premise if you give them some money. I think that's about right? That's a big surprise, yes. Okay, so what we're saying here is that we're going to use the image from Aerospike, and it's called Aerospike Server. And what we're going to do is use the latest version. Well, I'm a developer, of course I want the latest thing, I want the latest and greatest, and the fact that it might break is, I don't really care, I want the coolest thing. And we're also going to specify a volume that I'm mounting as well. So that's all pretty simple. And so you can see from the basic description of our Docker file how I can quickly orchestrate these 2 services. So that gets us, our developers happy, they have blessed this application as done. They swear they've tested it, they've regression tested it, and it's ready to go into production. They swear. All right, so we've talked about that. So to get into production, I'll put my operational hat on, and I'm going, yeah, kind of a single web node and a single database node. That doesn't sound very reliable. So what we're going to do is we're going to create a 3rd service for HA proxy, and HA proxy is just a load balancer, and we're going to put our web nodes behind that. Now, who's used HA proxy? A bunch of you, right? So the great thing about HA proxy is each time you add another node, you've got to do some reconfiguration, right? And I don't like typing anything, and we're going to show how we can automate all of that piece out. So each time we add a new container running our web application, we're going to automatically reconfigure HA proxy. Who likes the idea of that? At least I do, and some of you do too. Okay. And so that's going to get us to the point where we can have literally zillions of web nodes to deal with the scalability of our web hit counter. So that's the goal. Now, at this point, we need to talk about Docker networking. Who has had a look at MultiHost networking? A couple of you. Okay, so why do we like multi-host networking? Well, to be honest, if I was going to deploy this whole application on a single physical node out in the real world, then I should be chased down by all of you and murdered. This is clearly a poor idea. So you want to put your deployed application on as many physical nodes and as many data centers as you think is reasonable. So multi-host networking is here to solve the problem of I want to have a private network between all of these nodes that my containers can talk to. And so in the next part of the demo, we're going to have 4 engines running. We're going to have our regular bridge network so we can accept incoming HTTP traffic. But we're going to have this private network called prod on, using the overlay driver. And so what this is going to allow us to do is it's going to ensure that our database containers and our web containers are all talking on a private network away from the public facing IPs coming in. Right, so this gives us some isolation. So that's what we're going to set up. So let's demo that piece. All right, so once again, I've created a compose file, so let's just bring our compose file up. And as you can see, there's going to be 4 services now, and I'll talk about what those 4 services are doing in a second. And let's go back to our web page. If I do a page refresh, hurrah, right, we're back to 1. So we're running in production, and we can actually, we still got our nice scalable web counter. Now I've got a piece of visualization here, and you can actually see our swarm cluster. We've got 3 Docker engines running. You can see our database node here, and here's our web node. So that's pretty cool. Now, we did say we have to kind of connect all these networks together, so let me do that before I forget. So let me just connect, let me connect the networks. All right, so I need to connect a couple of the containers so that they're on both networks, right? So my HA proxy needs to be both on the public network because it's getting incoming traffic, but it also needs to be able to talk to the other containers on the private network. So let's just connect these up. And then there's a second discovery service, and I'll talk about that in a second. I need to do the same. All right, so doodle-doo-doo. So my web application's running, we can see it down below, and I can now use Docker Compose to scale. So I can simply now say scale where, whoops, even if I type it properly, it might work. Let's bring up 5 nodes. So what Compose is doing, it's seeing the request, I want to have 5 nodes, it's seeing there's 1 running, it starts for more processes. So if I do a Docker PS, you'll see all of that up and running. And if I go back to my visualization, you can now see all of the nodes sitting behind HA proxy. And if all the reconfiguration has happened correctly, when I do a page refresh, we'll see that we're getting the page refresh. Okay, so that's pretty cool. Let's now jump into the Aerospike command line and log on to the database and actually do some queries and have a look at the data. I've actually stuck this in a container as well. I got indoctrinated when I was at Docker to run everything in a container. So I'm going to run, I'm going to put myself on the prod network because I want to be on the inside. And then I'm going to run from the Aerospike repo. It's really difficult to type at this angle. I don't recommend it. We're going to run AQL, which is the Aerospike command line, and we're going to connect to the host called prod Aerospike 1. Oh, it helps if I say run. Okay, so here I am. I can do select start from test.hits. There you go, we've essentially recorded each one of those hits in a table. That's pretty cool. And if I do a select star from hits.summary, oops, even test.summary. What I've done is created another set of stats, so we're collecting the number of hits per web node. Right, so we can see that after I've added those extra nodes behind the HA proxy, we can actually see the stats are being collected for each one of those, and we can now aggregate them. Okay, so the data's real. We actually really are writing data to a database. It's not kind of, smoke and mirrors. Okay, so if I go back to here, so we scaled the web tier. Hurrah for us. Life is going good. The post on Hacker News is close. We're up to kind of 9 or 10 at the bottom of the list. And, our kind of DBA, our senior DBAs come in and going, I think we're reaching the capacity of a single node. I think we need to scale out. Oh, I suppose I should actually talk about let me talk about, before I do that, let's have a look at these, the compose file. So, this is the kind of great thing that I really do enjoy about compose. So, I've defined all my additional services here, the 4 services. We've got our HA proxy service, and what I've done is I've extended an additional service file. So what Docker Compose lets you do is essentially build on top of yourself and inject additional behavior at each step. So what I've done here is I've taken the basic definition and I've added in a constraint. And this constraint is going to tell Docker Swarm when this service gets deployed, or that container gets deployed, to put it on a specific node in that cluster. Right? So I can start controlling where those containers are running. And I've just injected that behavior based on the basic definition that the developer gave me. I've just extended it and put new behavior in. And if we look further down here, we can look at our Aerospike service, and our DBA insisted that we use a concrete version. So you can see here we're going to use the same Aerospike server, but we're going to use 371. So again, you can inject additional behavior as you go through that life cycle. I've also put this rule in here that I'm going to define this label called com.aerospike-cluster with a value of awesome counter. And you go, why would you want to do that? Well, I'm going to now add an affinity rule that says this container cannot run on a Docker engine where that label exists. So this is how you get, in our particular case, to ensure that only one Aerospike container is running on one Docker engine, right? Because you don't want multiple database processes on the same physical server, because if you lose that physical server, you lose all of those processes. So this ensures that the containers are running in a particular way on that topology. And so this is a great thing to think about as you go through that life cycle. Your developers will give you those basic set of dependency, and as you go through the DevOps and into production, you can inject the additional behavior or packages or additional constraints that you need in order to adhere to whatever standards that your organization has. Okay, so one service we haven't talked about is our discovery service. So what we're going to do in the next demo is scale out our web tier. And we'll come back to what this really means in a second. So, scaling out the web tier. And this comes to the magic. We're going to use Docker Compose. We're going to say scale Aerospike equals 3. Right, so I'm just going to add 2 more Aerospike nodes into this cluster. And you can see those services start. And if we go back to our visualization, you can see that those processes are now distributed in that cluster, and we should see that our web counter should still be working. It's still working, that's awesome. And so what we'll now do is we'll go and run an Aerospike command to go describe the topology of the cluster, and you'll now see the cluster has got 3 nodes. So let me just do that. And this is where I look to see whether I spell everything correctly. And so what this is going to do is it's going to go to the cluster, it's going to talk to all the nodes, and then it's going to give you a decomposition of the nodes in that cluster. And as you can see here, here are our 3 nodes, Aerospike 1, 2, and 3, and this is given some statistics of how many objects there are and their distribution and so on and so forth. So we've simply scaled the database tier by going to Docker Compose and saying scale equals the number. The cluster has self-formed underneath, and so that means you can actually scale out the database tier up and down by simply doing a Docker Compose, right? So this should make life a lot easier. How have we done that? So if I go back to our file, essentially I've got my discovery service, and the discovery service is there to kind of mesh the nodes together. And as you can see, it derives from an AES-based cluster. So if we look at that quickly, what we have here is a particular image called Interlock, and we'll talk about Interlock in a second. And what we have is a plugin for Interlock that essentially allows the capturing of those events of a container coming and going, and then it's seeing that it's an Aerospike node and then doing all the work to configure the cluster for you. So how do we do all of that? So what we use is the Docker Event API. So you can go to the Docker website. This is a slice of the state model. And as you can see here, there's a running state, and there are various events that you can get either to get into a running state or when you leave that state. So there's a remote API that you can call on Docker to see those events. Now, our good friend Evan at Docker created this framework called Interlock. And all Interlock does is it sits on those events and allows a sort of plugin framework so you can put in various plugins to respond to those events. Evan supplies HA proxy in a couple, and essentially what that plugin does for HA proxy is reconfigures HA proxy when it sees a web container arrive, and then reconfigures as that container disappears. And so Richard, who's sitting over there, say hello, Richard. Richard built our plugin for Aerospike, and essentially that follows the same pattern. It waits for a container to arrive, it sees it's running Aerospike, it matches some criteria, and then it introduces it into the cluster. When that container disappears, it then removes that node from the cluster automatically. So this is how we get the flexible provisioning and the expansion of the cluster on demand. If you've got lots of questions, go and talk to Richard. He's more than happy to talk about it. You can talk to me about it as well. But talking to the engineer is kind of what you really want to do, right? Okay, what does a plugin look like? It's a piece of Go code, and this is a sample from it, but essentially we get the event, we then run a configuration command on the Aerospike cluster, do some error handling and some various bits and pieces. You can go look at the source code. It's really easy to build these plugins, and you can actually do some really kind of cool things with it. All right, finally, some considerations. So where should I store my data? So what happens if I store my data inside my container? There's a prize. I'll give you one of these infamous Aerospike screwdrivers. It's ephemeral. And what's the side effect of it being ephemeral? You lose all your data. This could be awesome. There are certain circumstances where that's awesome. It's like a dev test machine on your laptop. You don't care if you lose all the data. So that's a good reason for losing data. For the most part, people kind of want to hang on to their data. So your other options are storing the data on the host the Docker engine is running on. And so that's kind of good because that you can then take advantage of any block device like a SSD that's attached to that host. The downside of that is clearly if you lose this host, what have you now lost? You've lost all your data again. Okay, so you can then, for example, if you're running in Amazon, you could actually put your data volume in an EBS volume, mount that to the host, have the container then mount across that. And so you then can take advantages of, say, an EBS snapshot for doing backup and restore, and so on and so forth. So those are the two obvious ways. There is a third way, which is you can use a data container. And a data container looks like a container, and you can store data in it. And you can use this -- volumes from command line, which essentially allows this container to pull data and push data into the file system inside that container. Data containers have got some special rules, like they're kind of difficult to delete. If you shut it down, you don't lose the data. You actually have to go out of your way to destroy the things. So there are some safety things in there. Clearly, you've got some kind of performance issues, which we're still trying to characterize and understand internally ourselves, because this is a process hot. You've got a tunnel between. So this is something that you could look at and consider. We don't have an opinion about this right yet. Is there more of an opinion from Docker yet? Not yet. Okay, perfect. I didn't say anything wrong there. Okay, so the summary is databases and containers are actually quite a good idea. They allow you to use the same management paradigms you've got for your application code. You can inject behavior through the life cycle. So you can put affinity rules, you can put in extra dependencies, you can do management. If you pick the right database, then you've got the ability to scale up and scale out as needed dynamically. You don't have to sit there bashing away at a console, reconfiguring your database just because a node has moved or a node has gone away. So you want to make it as easy for yourself as you can. We think the combination of Aerospike and containers, we're a bit biased, so this is the bit of biased opinion. We think it's a great match. We'd love to hear what you think when you actually use Aerospike and containers in production. Codes here, there's the Docker images, there's our deployment guide, contact me, tweet me. Here are all the ways of getting in contact. So I think we've got some time to do some Q&A before we jump onto the next speakers. Questions?
In the application, in the Python application, how do you connect to a cluster, your Aerospike cluster? Because I saw that you can make a string, and if you have more than one machine, how do you decide to which machine you connect, or how that cluster interaction works?
Yeah, so the question is, how do I connect to a cluster? If I put a single IP address in, for example, that may not be there sometime later. So, like all of these solutions, you can specify a list. And I didn't put a list in this just to make the code simpler, a little bit more readable. But essentially, all you've got to do is the ability to connect to one node, any node, and then that node will be able to tell the client about the rest of the topology.
Consistency story for Aerospike? What are the options for consistency?
Okay, so the question is, what's the consistency option? So essentially, Aerospike is an AP system. So data is, we essentially write to a primary. The data is then synchronously replicated depending on the replication factor you specify. So that's all done, and we also allow you to do replication between clusters, and that's done asynchronously.
So it's eventually consistent with NoSQL, or?
The question is it eventually consistent? Essentially queries are always going to go to the primary, right? So you're always going to see the current state of that object or that record. It's not like on other systems where you could potentially use secondaries for read scalability. Then you have to deal with eventual consistency. The cases where you get into eventual consistency is if you have two clusters and they are doing replication between them. And so one of the features that we're working on this year is to do essentially conflict resolution and detection. So if you're doing writes on two separate clusters and doing the synchronization, you need to know if the object has changed on the other side and be able to compensate for that by either doing a last write wins or providing some application logic in order to determine which version to use.
eventually become like a single cluster?
I'm not sure what you mean exactly.
Well, they are not independent running, so if you synchronize their writes, eventually it's like a single cluster.
Yes, sure, but the replication between clusters is asynchronous. Yes, it's not synchronous. So it's synchronous within an intra-cluster, inter-cluster it's async.
How do you compare it to Couchbase, which is actually more kind of close to you because you're in basically a hash map store, which Couchbase being before Membase. So it's actually closer to you. I had only comparisons to Cassandra and MongoDB. One of them is Coleman, the other one is Document. So how do you compare to Couchbase?
All right, so it's a fairly broad question. I'll try and do it as quickly as possible before I hand over to my colleagues over here. So Aerospike's a key value store. Mongo is a document store. Cassandra's wide column. You could describe Couchbase as either a key value store or a document store, depending on what is convenient. Essentially, the fundamental principle of Aerospike is that we were designed from Flash from the get-go. And so our belief is that if you write large blocks out to a Flash device and you're doing it in a sort of log structured way, i.e. you're not doing overwrites, then you can actually maintain not only the reliability but the performance and the latency of those drives over time. So typically we see customers in fairly low spec in terms of CPU. They can put 486 flash drives and we can run 2 million plus transactions a second out of a single node. And that's because, if you took the slide at the beginning, we massively parallelize those writes. We don't have all of the essential file system and page cache and all the block interface to go through. We go directly to those drives. And so we can get orders of magnitude in performance improvements by doing that.
You take in consideration also the life of the drives, because I've seen some talks about, for instance, using Couchbase on SSDs, but the life of the drives was very, very short when they're trying to use like smaller drives. So how do you address this problem in production?
Yeah, great question, which is how do you preserve the life of your SSDs? You preserve the life by not rewriting the same block again and again and again and again and again and again and again. So if you've got a write-in-place model like, say, MongoDB, you will burn your drives real fast. So a lot of the work and a lot of the IP of our products is in that log structure file system. And it's designed in such a way that we can actually not only take advantage of the new technologies like NVMe, but also some of the Intel 3DX point transactional memory. When that becomes available, we'll be able to exploit that in a similar kind of way. So our kind of mantra is speed at scale. You don't necessarily have to have a speed problem to use Aerospike. It's very flexible. It's a very typical NoSQL key value store, but it's got some specific properties that allow you to really drive the utilization from the hardware you've got that you won't see out of any other solution, in my opinion. A man with a kudo shirt.
Sure. With the sequential writes, do you have some type of compaction that runs at a certain point to reduce data size?
Yep, so this will be the last question and I'll move on. Absolutely, so we've got to do compaction. Our compaction is all done on high water marking of blocks. We look at how sparse the block is populated with live data, and we use that as a constant compaction that's going on in the background. We don't do it periodically like, for example, a Cassandra would do. This also integrates with our time to live. So we've got inbuilt TTL, which means you can expire data out automatically from the database. Okay, I'm going to be around, so please stay around and ask any other questions. I think it's time for Mike and Banjo. Mike.